Let's go ahead and look at another scenario about airplanes. An airplane 30,000 feet above Denver begins descending at a rate of 2,000 feet per minute. Write an equation to model this situation. So before I even start to dissect this sentence or sentences and identify my variables, I know right away that this is going to have a negative slope because that word descending, okay? And I also can tell right away that I'm going to write this equation as one in slope-intercept form. And the reason I know that is because I am given a rate of change. When I'm given the rate of change or the slope, and I'm given an initial amount, and in this case, it's an initial height, I'm going to be able to write an equation in slope-intercept form because remember, slope-intercept form is easy to do when you're given the slope or the rate of change, and then you're also given the y-intercept, and in this case, it's the initial amount. So now that I know I'm going to do that, let's go ahead and identify the variables. So let's see here. I'm going to read it again. It starts at 30,000 feet and it's descending at a rate of 2,000 feet per minute. So right away, I know that x is going to be equal to, or whatever variable I choose, it doesn't have to be x, but it's going to stand for the number of minutes because I don't know how long this airplane is descending. So I'm going to go ahead and write that as one of my variables, the number of minutes. And actually, let's pick the variable m, just to show you that it doesn't matter if you use x and y. The reason you see that x and y so often used is because of coordinate plane graphing. But let's just go ahead and use two different variables. So now I'm going to use the variable m to stand for the number of minutes. And then I'm also trying to figure out, I believe I'm going to be figuring out the height of the airplane. So I'm going to use the variable h, and I'm going to say h is going to stand for the height. It's sometimes called altitude of the plane. Okay. So now in order to do this, I need to determine the rate of change, which is the slope, and the y-intercept or the initial amount. So let's start with the 30,000 because that's the height of the airplane when the plane first begins descending. So that's going to be my y-intercept. B is equal to 30,000 feet. So when I'm writing the equation, that plus value is going to be 30,000. The next thing I need to figure out, and since I used m and h, I'm going to write it as h equals. Height equals something times m. And this number that I'm going to multiply by n is my rate of change. What is the ratio, or how many feet is this airplane descending per minute? And again, that word descending means that it's going down. So the height is actually going to be decreasing. So when I'm calculating my slope or my m value, I just realized I used m and m, sorry about that. It's going to be decreasing, it tells us right here, 2,000 feet per minute. So I'm going to write that as negative 2,000 feet for every 1 minute of time. So my slope is actually going to be negative 2,000. So let's write it one more time. H equals the rate of change, or the slope, is negative 2,000 m, and m stands for the number of minutes, plus 30,000, which is the initial height of the airplane. So now we're going to use this equation that we just wrote to answer some questions. I'm going to write it again. H equals negative 2,000 m plus 30,000. My first question asks, what is the height or the altitude of the airplane after exactly 5 minutes? Remember that we determined that M in our equation is going to stand for number of minutes. We also determined that the H was going to stand for the final height or altitude of the airplane. So since we have M as 5 minutes, I'm going to substitute that into the equation, and I'm going to replace the M with 5. So H is equal to, negative 2,000 times 5 plus the initial height of 30,000. Negative 2,000 times 5 is negative 10,000. And negative 10,000 plus 30,000 is equal to 20,000 feet. So that means that after 5 minutes of descending, the airplane will be at a height of 20,000 feet. Okay, one more question about the airplane. After how many minutes will the plane be exactly 10,000 feet above Denver? So on this example, we are given the height. We are not given the number of minutes. We're trying to figure out the number of minutes. So I'm going to substitute this value into my equation in the place of H. So now I'm going to write it as 10,000 equals negative 2,000 times M plus 30,000. And now I'm going to use inverse operations to solve this equation and solve for M. I'm going to start by subtracting 30,000 from both sides. 10,000 minus 30,000 is negative 20,000. So then I have negative 20,000 is equal to negative 2,000 times M. If I use inverse operations, the inverse of multiplying by negative 2,000 is dividing by 2,000, or dividing by negative 2,000. So now I'm going to divide both sides by negative 2,000. Negative 20,000 divided by negative 2,000 is 10. And by the way, a negative divided by a negative is a positive, in case you don't remember. I ran out of space, so you can't see that step, but I'm dividing both sides by negative 2,000, and I get M equals 10. So that means after 10 minutes, the airplane will be exactly 10,000 feet above Denver.